Direct variation. All right, we've already talked about direct variation, but here's the actual definition. It's a special type of linear relationship that when written in the form y equals kx, k is a non-zero constant called the constant variation. Okay, basically that means constant change. So we just studied something that was constant change. It was m, which is slope, the rate of change. So this is constant change. It's constantly changing, just like the slope does to x. In fact, k in this linear function is considered slope. The reason why it's called k is because it's being multiplied to x, and it has a slightly different definition than the rate of change or slope. It's constant variation. So basically the same setup. Now here's one really important thing that you can remember. On a graph, you notice this doesn't have plus b. When we studied y equals mx plus b, it doesn't have the plus b, the y-intercept. So that means the y-intercept is 0. So this, with direct variation, it always crosses the graph at 0, 0, the origin. So how to figure out if an equation varies directly? We want to solve it for y. If it looks like this, then we're good. So let's do that. To solve this for y, I have to move the 2x to the other side, so subtract 2x from both sides. And I get y equals negative 2x plus 10. Because of this plus 10, that means it's not direct variation, because it has that plus 10. Now, if it was just that, then it would be. But because it has that plus 10, it's not direct variation. All right, how to tell if it's direct variation using a data table. So let's see this. We want to see if it varies directly, if it can be written in this form, kx. So, how do I multiply? Can I multiply 1 by something to get 6? Well, I can. I multiply it by 6 each time. So we multiply by 6. 3 times 6 is 18. 5 times 6 is 30. 7 times 6 is 42, and so forth. So we are multiplying by something every time. So it's directly related to 6. So y equals 6x. Alright, so that's direct variation. That's how you can tell if it's directly variated associated to the graph. So let's go on. Now, if the values x and y vary directly, and y is 6, x is 12, find y. So this is telling you to find the equation for the varying directly. This is actually pretty easy. You write the direct vary equation, which is that, and you're going to plug in the values. So x is 12, that means 12 is going to go here. Y is 6, so 6 is going to go here. And now we're going to solve for k. What does k have to be so that this makes sense? Well, to solve this for k, all we have to do is divide by 12 on both sides. So we get k is equal to 1/2. So when I rewrite my equation, don't forget, when you rewrite your equation, it's with y and x. So y equals kx. Instead of k, we're going to write the 1/2. And that's the varying directly equation for this situation. That's pretty much it. So when you get in class tomorrow, we're going to actually do stations involving this, and we'll practice each type. That's it, folks.